Hey, everybody, welcome back. Lecture day 6. We're going to bleed into a new module today. There's some starter code up and in the announcement. It's literally what we did last time, but I stripped out some of the comments and all the recursive stuff. I want to build off what we were talking about last time. So if you want to grab it and copy and paste it into your code, you'll have a good start. If you did it before I deleted this prototype up here, you'll have to take it out yourself. I guess I should throw some name on it. CSCI 02, lecture day 6. New, delete, and Destructors. What's today? It's day February 7th. Don't mind me, I'm just up here teaching. This is not how you make it to the favorite employee of the month club. All right, we were talking about this last time. We were saying the comment or the problems with arrays. First off, we have to declare their size ahead of time. That sucks. And deleting stuff from the middle kind of sucked. If we wanted to get rid of AR1, for example, you should be able to use the example, or let's see. We don't even need that line right there. This operation right here, this for loop, gets rid of position 1. And you should be able to put null here instead of 0. There we go, went purple. Let's just make sure I didn't fuck anything up. We'll run it again real quick. No, of course I did. What did you not like? It's the naming thing. Let me copy and paste this. Make a new one. It's very picky on name length, which is weird because I can make programs with longer names. CSCI 02, should be 06. Delete and destruct. Again. All right, that's too long. That's not too fucking long. Zoom bar keeps getting in the way. Always in the way, poor zoom bar. Okay, this is what we had. All right, run. There we go. Okay. So something you should do frequently when you're testing these, whether a situation works well or not, is, I'm gonna make a new variable. I'm gonna call it int temp. And I'm gonna start with 0. And I'm gonna change this loop right here, the delete loop that deletes something, to delete from temp. So I will start deleting from position temp. Maybe I'll copy and put that, maybe I'll put this down here just for ease of presentation. Okay, so 3 things you should check when you're trying to see if like a delete or add works in your program. For delete or add in the middle kind of thing, in a operation or a command, you should check not just the middle, but the beginning and the end. So I'm going to set, this was array size 5. I'm going to tell it to delete from position 4. That's deleting the last one. Let's see if that works. It doesn't. Why? Line 36. Truncation from int. That can't be why. This temp, oh, temp was already defined. That's my bad. I didn't think I'm even using n here. We'll get rid of that too. Okay. Okay, so 4 was storing 168. Now it's storing 0. I'll add some more to this. I'm just gonna copy and paste it twice. Here, I'm gonna change between the first 2. I'm gonna change temp to get rid of the middle. So temp equals 2 now. And then after we run it once, I don't think that's the right spot. Let's see. No, it's not. It needs to go after this. No, that was right. It was here and here. So temp 4, we'll do temp 2 here. And then temp 0 is getting rid of the initial one. So on temp 4, I'm deleting the end. Temp 4 is deleting the end. And temp 2 is we are testing our delete structure, not structure, loop on a middle element of the array. And then on temp 0, we're testing the first element. So it's good practice. Check the beginning and the middle. Because in the middle is where it's going to work, but it should be like if we were to make a function out of this, you want to be able to delete the beginning and the end as well. Let's see if that worked. So we start off with all 5 elements populated, then The last one was deleted. And then we said delete 2. 2 was 13. And the next loop is missing the 13. And then we said delete the first element, which was 1, and now it's missing the 1. So this for loop worked on for all of them. For any position. This kind of sucks though. There's a lot of coding to change a couple elements out of an array, right? And it sucks that we have everything put at runtime. This all sucks. Well, the problem is we do not have what is called dynamic memory allocation, which happens at runtime, not compile time. Everything above was done at compile time. This kind of sucks because if we don't want something anymore, it's kind of pain in the ass, but to get it rid of. If we have int x equals 5, I can delete x. I didn't do anything. Stuck with it. Stuck. Now, int x equals 5 isn't a problem. But what if this is your BBEG? Does anyone know what that stands for? Big bad evil guy. What if this is your big bad evil guy and you kill him in the game? You know the BBEG's hogging up a lot of memory. He's got a lot of special attack moves. He's fucking big. He's got a lot of animations. He's got to look cool because he's one of the main bad guys. He's a boss. So like he's eating up a lot of your memory and you do not want all that shit eaten up. And having him stuck in the game kind of sucks. You want to be able to delete him out. So that's what's helpful about dynamic memory allocation. And that's where we have the new command. And it helps to use pointers. So instead, I could do a pointer y equals new int, and we'll just say it's 10. So we can see out y. And maybe we should see out dereferenced y. Because see out y is going to give me what? What do pointers do? Pointers give you an address. This is an address to where the 10 is stored. So let's comment out all the other crap up above, because it's just going to clutter our screen for a little bit. And I done pissed it off. Whatever I did pissed it off. Why? There you go. Now it's running. It's weird. So give me the address in hexadecimal, of course. But now what? Now, delete y. And there's no issues. Couldn't delete X earlier. This just deallocates the memory. Our pointer Y still exists. And now it's pointing at something you can't reference. Let's verify that. I deleted it. Let's see what happens if I try to do a C out Y again. I didn't like it. I didn't like me accessing the memory there. It got all the way up to that point. It showed me a pointer for it. The pointer was still there. It had a new pointer this time. I don't know why that changed between the two lines. But when I tried to dereference it, I can't access the memory anymore. So something you should do, let me hit end task. Something you should do when you delete is set Y equal to null pointer. When you delete a pointer, set it to null. So any accidental reference doesn't fuck shit up. Doesn't redden it. I've made it a null pointer. Now let's see what happens if I run it. Oh, really? Still doesn't like the null pointer. That sucks. Maybe it never did. Maybe I'm just tripping. We can reuse it though. If I had int x equals 5, I can actually reassign it to the address of x. And now it's pointing to the x equals 5. So pointers are you're stuck with. But pointers don't take up a lot of fucking space. It's just an arrow. It's just an arrow to a location. So we are stuck with the pointers, but they take up like 4 bytes or some shit like that. Not as much as our BBEG. Who's that bitch on Elden Ring? The fucking flies, the rot bitch. Millennia. She's not Millennia. She's I don't like using the C word because it's very derogatory. But Millennia is a C word. I won't call a real lady in person that because it's fucking
In
wrong.
Elden Ring that flies with rot.
Yeah.
He's talking about Millennia, but the way he said that, it's just funny. He said,
I
who's
said
that
Millennia.
bitch? Watching.
Malenia. She's a count. She's a count. I just don't know how to spell it right. I hate her. All right. She's a C out. I like that. She's a C out. All right. So we got this new shit going on here. What about for arrays? So we want to do an array. We can do, let's do a array pointer. I'm going to say new int. And rather than using parentheses, I'm going to use brackets. And this will tells it to make an array of size 5 at runtime. Not compile time. So we'd have to go through and populate it. Maybe I'll just make a quick loop. For int I equals 0. I don't know if this is actually faster. ARI equals I. And I had a for loop above that printed the shit out. So I'm going to go grab that real quick. No point in reinventing the goddamn wheel. Might as well make it friendly. Reusable. So will this work? What? Let's check. So Juan noticed something that is important. We come up here, all the way up to our array up here, it was constant size equals 5. Because it can't change after compile time. So the size 5 had to be constant because it was an array. But now we're down here, we're doing a pointer. And since it's done at runtime, not compile time, it doesn't need to be constant anymore because it's adaptable. So see out. Please enter an array size. Size. So maybe I'll put this right above it. Can I change the size of the array? Yes, I can. I declared the size of the array at runtime. Fuck fixed size arrays. Handy, right? Right? Boom! The fuck does Redden waste all our time on last semester? Right? Pointers are kind of deep. Pointers a lot of people struggle with. So like it's better to ease your way into it. You guys have seen pointers a few times now, so like it's pretty handy. Of course, we're still hogging up memory. So how do we delete an array? Anyone remember? There was no deleting an array before, was there? Can I do delete array? See if it works. Oh, you dirty bastard. It's not supposed to work. You're supposed to tell it. Actually, let me do this after it and see what happens. So we're going to delete the array, we're going to print the array, we're going to delete the array, and then we're going to print the array again and see what's changed, if anything. Oh, it definitely didn't like it. And it didn't like it. Notice it did the AR0. That's just the ARN. So it didn't like, it is actually deleted. That's good. Close. Oh, stop. There we go. So it's actually deleted. So, or is it? What is array here? The pointer array. What is ARR pointing to? It's pointing to the first element of array, right? Can I still access later elements? Damn it. Let's try it. Nope, didn't like that either. Why? A only pointed to the first goddamn thing. Or ARR only pointed to the first thing. We've deleted the reference to that point, so it doesn't know how to connect to the rest of the chain. It doesn't know how to find the rest of the array. So that doesn't work either. Like, do it up here or afterwards? 4, all right. Why is it not like that? Size minus 2. The address. I'm trying to make a pointer. I need to make the fucking pointer. And we'll change this to Z. Or dereference Z. So it's still there. That was not Z. Do I need to just do Z? It's still pointing at something. It still knows where the location is. So let's get rid of that. A good way to make sure that we fuck up all of the array is to delete with brackets like that. So this should fuck up all of the array. But array is still a pointer here. ARR is still a pointer. So I'm going to say ARR equals no pointer. And even though it pointed to an array previously, I can point it to the address of X and then do C out array. Ah, it showed me I didn't dereference it. But it showed me the address there. Let's dereference it this time. And show that it still accesses that element. Or still goes or uses not that element, but it's changed. There you go. So I had a pointer, I declared it when I did it first was for an array. And when I deleted it, I was able to reassign it to a non-array, which is handy. So this whole thing we did up here with doing prompting for the size, this is dynamic memory allocation. What we wanted for memory was declared at runtime. By prompts from the user. How's that for fun? All right, it's time to revisit classes. We learned about constructors before, and the opposite of constructing something is destructing something. I'm going to come over to the modules, and we're going to steal some code, some preliminary code, come down to module number 3, I think it is. We're going to do the dynamic memory in C++ tab. Notice what we're leading into, singly linked lists. This is the good shit. This is the Hefe needs his camera out. Not today, but when we do linked lists. All right, so let me comment out everything we had there. The quick way is by doing this. Putting that at the end without having a fucking metric ton of ugly shit. What is, it didn't end it. Why is it not ending it?
It ends right there. There's something in there that ends it for whatever reason.
Oh, was it?
Right there.
Oh, right, okay. There you go. Okay, so let me go steal that shit now. Just do this first part for now, see what we get through. All right, so this looks like we are looking at something. Oh, this is in module 3, dynamic, what was it called? Dynamic memory in C++. All right, so it's reminding us that this would be normally in another class. We've got a class line. We've got 2 variables, M and B. So it looks like we're doing the slope intercept form of a line. We have a default constructor set. We have accessor methods. Okay, so constructor, we have our accessor methods. We have a utility method. And this motherfucker right here, this bad boy, is our destructor, which I guess it says afterwards. Note that it has the same command setup line like we have above. When we do a constructor, we got to do the name of the class followed by parentheses. We do the same thing right here, but it has a tilde in front of it. Tilde on a PC keyboard is next to the 1. And I usually need, I think I need the function key or the shift key when I do it. Let's see. Yep, that's not it. That's it. On a Mac, I don't know where it's at. Find it yourself. Is it? Good. You never know. All right, so what does it do? What do you guys think it does? What's the constructor do? It does what? Well, the first thing it does before we have any input whatsoever is it assigns memory space and then populates it. So with that in mind, what's the destructor do? It does the opposite, right? It deallocates the memory. Okay. So let's go look and see what else is going on in here. Let me wait and let you guys time to write this. All right, so we're looking at the main. There's 2 lines, F and G. F has constructor setup. G is using the default constructor. What happens if I don't have that constructor in there? Will this run? It's only getting mad at F, not G. Okay, let's make this 2 different lines. Let's say this is line G, this is line F, and let's turn off line F and see if it allows us to do line G. I guess I gotta dereference any comment about F. So it doesn't like it. Doesn't like all the accessor methods without it. Good to know. Let's turn it back on. Turned off F somewhere. Right there. Then we've got using the print line, blah, blah, blah. And here we are stuck with F and G for the life of the program. Because we didn't use pointers, so there's no new going on. Okay. Let's just run it and see what happens. Three and 9. Oh, that looks terrible. How many lines in your list? What is this? Oh, gotta do it for each line? No, hell no. Let's not do that. So I don't like the way this is set up. I'm gonna do enter M for your line. Because I think it looks tacky. And then we're gonna say enter B for your line. Having them back to back where the person just enters twice, numbers twice in a row, the user doesn't know what they're doing. They don't know if they're supposed to hit enter between them, what's going on. So here we've got a new line. And when I put my cursor over it, look what it says. It says line and it says dereference line pointer. Or it's actually, you could move the asterisk to the other one. This says this is a pointer. Is it a pointer? Will that give me the address? Let's just check. It's right after I enter the M and B. Yeah, gives me an address. So even though I didn't tell it was a pointer, did I? There's nothing here indicating pointer. The fact that we have new here is telling it to make it a pointer. Telling the IDE that line PTR is a pointer. What? Oh, it's up there. Never mind. My bad. I'm like, that doesn't seem right, but I was running with it. Seems kind of silly to have it in two spots, right? Seems like we could do this right here. Just put that bad boy right there. Comment out that. And do it right away. Let's do that. All right, so it's printing the line, it's dereferencing. What is it doing here? What is this doing? Let's think about it. So line pointer, and it's doing the arrow, is doing the print line. It says run the print line program. Then it's dereferencing it. And it ran it twice. We got y equals 3x plus 4 and y equals 3x plus 4. One of them is coming from this, and one of them is coming from this. But they both do the same thing. So these two, this is the same as the dereference line below. This is the same as the line pointer or the arrow above. One of these is easier to remember. I think the arrow is easier to remember. Unfortunately, if I do line PTR dot, and then I do print line, it will change it to an arrow. The reason why I say that's unfortunate is it's really fucking handy if you're using this IDE. But if you're not using this IDE and you're using one that doesn't do it, and you start typing in dot and it doesn't change it to an arrow, it ain't gonna do anything. It's gonna say, what the fuck are you doing? So you might be better off at least getting used to doing the arrow operator yourself. Okay, it's worth noting. Then we have delete line pointer and line pointer null. Good. Let's come down and look at what, oh, here's the, now there's an array of lines. And we want to enter a bunch of lines. Jared,
Is there a reason to use null instead of null pointer?
null is a value, null pointer is a null pointer.
If you use null here, we use null pointer before. but null pointer-
Did I? I see it. Huh. Maybe the IDE allows it. It used to be not the same.
I think it's just fine with the value of null, whereas the other one is fine with this is- there's nothing on this pointer.
But this is a pointer. Line pointer is a pointer. So pointing it to a value, we're saying it's a value with an undefined location is kind of weird.
You're saying that the address.
Fuck all that. Let's make it null pointer. We'll fix that right now. All right, so here it's how many lines on a list? I'll say 3. We're gonna do 1 and 1. I didn't change the M and B prompt here. 2 and 2 and 3 and 3. And it shows all lines, and then it's got something else down here. So what is that? So here's the command line to populate them. This is the print line. That is showing me the integer address of where line array was pointing. And it did again here. What else did I want to say about this? Oh, the entire point of this conversation was fucking the destructor. I never did the destructor. We have it up here, right? I made one, but I never called it in the main, right? I said delete line pointer and line pointer equals null PTR. This is a free call to the destructor. When you delete, it does a free call. Free call to the destructor. Nothing in here deleted F or G. So how do we delete F or G? I can say delete, or I can say F dot tilde line like that. So this is the other way of doing a specific destructor call, like calling it without doing a delete. Bless you. So let's come down and look at what's in the stuff down below. This is just our basic setup here. Our constructor. Our lines, our print line. Destructor's empty. We can populate it with comments though, if we want. So we can make it so like, you don't have to do anything in it. But if you wanted, in this case, in the next example, the destructor actually has to do something. So, but I want to run it and show you just doing the C out here. Oop, something pissed it off. It's not running already. Oh no, fuck, I thought I turned it off already. Oh well, 1 and 1. The line got fucking terminated 3 times. Why?
What is only a perspective fault? Because it's all of it is actually the other people who do that.
Oh, from that one. Okay, yeah.
So does the Destructor actually erase everything for you without having to do it?
It deallocates the memory for that specific object that you've created. So this deallocates the memory for the line. If I have something else in this, like if I have something else in the class line that points to another object, that pointer still remains in effect. That other object still remains in effect, and we need to do something. We can have the destructor destroy it along there. So we're going to do that in the next example. You guys ready for another example? All right, let's turn off all this shit. Again, it didn't like it. Which means it happened somewhere else. Oh. And it's happening there. Okay. Let's do this. Let's just comment it out the good old fashioned way. I didn't want to have to do this. It's going to make me do this. Part of it's already done. All right, here we go. Down to the bottom. Let's come over to our module again and grab the next page. Not the next page, but down below. So destructor call sequence for composition, it says. All right. So we've got an IO stream, we got string, we've got a class student. The student stores their first name, their last name, their ID. There's a default constructor. There is a constructor where we can put everything in. There's a print method. There's a destructor method. The instructor class has all that information for the instructor, plus the instructor has a student assistant. So it has a pointer to a student assistant. So this is like doing a pointer within another kind of thing. Class call within another class. So we have our instructor, default constructor, one that takes in everything. And then we've got destructor methods. And I encourage you to play around with this code, learn from it. So I made an instructor pointer, Mr. Jones equals new instructor, me, David Jones. My ID is going to be 007. And I have a new student assistant whose ID is going to be 666. And then we've got the Mr. Jones print instructor. And then I've only got delete Mr. Jones. Even though I've got a new student here, I only have delete Mr. Jones before the main ends. Instructor David Jones, 7. Didn't give me my 007, I'm fucking rude. Assigned assistant, Juan. End of program task. Instructor, destructor called. Deallocating memory for assistant. That calls the student destructor. Student destructor called. Mission complete, student destroyed. And then the instructor deallocation sequence is complete. So what's going on there? Oop. So we got the student implementer. This part is for the student destructor. So it says student destructor called, mission complete, student destroyed. And then the instructor destructor. That's a mouthful. Instructor destructor. So it says instructor destructor called, deallocating memory for assistant. Delete assistant. And then we have to assign the assistant to null pointer. So we didn't have this in the main because it was done in the constructor for instructor. When I say we didn't have this, we didn't create the assistant in the main. I can spell assistant. I mean, it sort of was, but there was no like code in there. It says like, there's the assistant right there. Can we do other stuff with it? Does this take place before the thing is destroyed or after? Can I come in and say mission complete? Let's come in here and edit this. Student dot first name. Get. This is assistant. Nope. Student dot first, get first name. Well, now will this say Juan's been destroyed? Just do get first name. Maybe I don't need the get because I'm already in the class. His first name. Juan's destroyed. Yeah. I like that. Juan was spending too much time with my arch nemesis, Mr. Redden. The dreaded Redded.
When you say that, I imagine my skeleton.
That's right. He fucking taunted me as a new hire, telling me I'll never get teacher of the year, fucking waved his fucking teacher of the year award in my face. for no fucking reason other than it was my first year, so I had arranged a field trip to NASA for the Mesa students. And the students all fucking really liked me that year, and he was getting jealous. He was getting jealous of all the attention Tefe was getting. So he had to come and try to bring me down. So we've had a rivalry since. That's kind of neat. So what does this tell you? The student isn't destructed until this is complete. This destructor call is finished. That's why I did this. I wanted to make sure to show you, because if it destroyed it on call, Juan's name would not be available. Right? And it's much better to say Juan's destroyed rather than David's destroyed. That doesn't sound right. That doesn't sound right at all, right? So we've got the new. We got new acts as a pointer. We use it with pointers, I should say. We use it with pointers because student assistant was a pointer. And when we use new for dynamic memory allocation, we need to delete. We also did it here, new instructor. So I deleted Mr. Jones, and the delete call for Juan was within the destructor call. So that doesn't need to be done twice. That's today's lessons. New, delete, destructor. Yeah, the null. Any questions?
Make it so that if you defeat one, like you get like a secret boss that can do it.
I like this.
That's the fun.
Can I access the professor in this? And if I can't, why not? Can I access it? Well, this should run. Let's just do it. So Professor Reign Supreme. Can I put in Professor David Reign Supreme? How can I edit this? Or can I edit this? Any ideas? That's the problem, right? The professor is not in the scope of the student. So we would have to pass in the professor. Which seems kind of weird. I like that. Professor creates student in the in the professor class, and in the student class, the professors reference like a circular thing. Let's see if we can make that happen. Kind of curious. So let's come up here to this and we'll say it takes in an instructor. Pointer.
Oh, wait, no, if you go to, no, it should be. But it's already inside of the class of the student, it's already. Oh, shit. So if you go to the top of the class. Oh, no, no.
No, they're not narrated.
Were you looking at the instructor class? Maybe? No, the instructor class is pretty- If it were inherited, it would probably-
A destructor may not have parameters. So I cannot do it.
Can we use templates?
Can we use what? I don't know how we would. Doesn't change the fact that I can't do a call there. And professor is not in student. So we would have to make a link up here to refer back to the professor that created him. That's deep. Let's not try that.
The professor makes the student, then discloses the student, then uses the student to get back to themselves.
I think I cleaned everything up. All right, any questions? Let's wrap this shit up then. You are free to go or stick around and let Juan tell you how it is.
So what does she up to?
I what? I didn't do shit. Maybe you hit your camera on accident. I like, you know, like when you turn to talk, maybe your butt hit it or something.